Welcome back. Now, still on complex number. Now, let's solve this example under polar form of complex number. Now, if you look at this example now, we're given express 1 minus I. This is 1 minus I. All square in the form R cos theta plus I sin theta. Now, it means we are given in Cartesian form and we are told to convert to polar form. Do you understand? So don't forget, if you are just watching this video for the very first time, please do well to click on the playlist below this video. When you click on the playlist, it will take you to the list of videos we've done. So we want to use the formulas we proved in the previous video to solve this question. Now, how do you go about it? Now let's bring out the question. We're given 1 minus I all square. Now the first thing is what? 1 minus I all square means 1 minus I in two places, right? Means 1 minus I in two places. Now let's expand it. What do we have? 1 multiplied by 1 will give us 1. 1 multiplied by minus I will give us minus I. Minus I multiplied by 1 will give us minus I, right? Minus I multiplied by minus I will give us plus I square. I don't know if you understand. Now what do we have? We have 1 minus I will give us minus 2I plus I square. Then what do we do? You say recall. You will recall that what is our I square? Recall that I square is equals to what? Minus 1, right? You know, when in complex number, when you have I is square root of minus 1, right? So when you now have I square, it means when I square both sides, if I square both sides, I'll square here. What will be my I square? My I square will be minus 1. Do you understand? So now let's go. So what are we going to have? We have 1 minus 2I. Then plus, what is this I square now? The I square is now what? Minus 1. So what do we now have? We have 1 minus 2I. Plus times minus will give us minus I, right? Sorry, minus 1. Plus times minus will give us minus 1. So when we collect like things, that will be 1 minus 1 minus 2I. So that will give us what? 0 minus 2I, right? So this is what we got, right? So we can just say, let our Z, that is, let's put this in, it's in form of complex number. So let's say Z is equals to 0 minus 2I. Let's just represent it as our complex number. Now let Z equals to 0 minus 2I. So when we compare with Z is equals to X plus IY. When we compare with Z is equals to X plus IY, what do we have now? When we compare this guy and this guy, so what is our X? Therefore, our X is what? Our X is equals to 0, right? And our Y is equals to what? Our X is represented as what? 0, and our Y is represented as what? The coefficient of this imaginary I is Y. Why the coefficient of this imaginary I here is what? Minus 2. Don't forget, I always tell you to take it with the sign. Always take it with the sign. So now you see that we've gotten our Cartesian form, X and Y. So we are converting it to what? Don't forget, we are converting it to polar form. They say express this guy in form of this guy. So you should know that it is in Cartesian form before and want to express it in form of what? Polar form. And what are the two formulas we are going to use? Don't forget, from the previous video, if you have not watched the playlist now, click on the playlist now and go and watch it. So the formula for getting our polar form, which is the R and theta, which is the magnitude and the argument, right? So what's the formula for getting the argument, which is theta equals to what? Tan inverse, right? That's tan inverse of Y over X. This is the formula, right? Theta equals to tan inverse of Y over X. Now what are we going to have? That will be theta equals to tan inverse of, what's our Y? Our Y is minus 2 divided by, what's our X? 0, right? Then that will give us, theta will now be equals to tan inverse of, minus 2 divided by 0 will give us what? Will give us infinity. Minus 2 divided by 0 will give us infinity. So now tan inverse of infinity will be what? That's 90 degree or 270 degree. Tan inverse of infinity will be what? Will be math error. So when you now press tan 90, you see that it will also give you math error. And when you press tan 270, so it will also be what? Math error. That's tan of 90 and 270. It will give us infinity. So tan inverse of infinity is 90 degree or what? Or 270 degree. But which one are we going to pick among these two? Is it 90 degree or 270 degree? That's why you now come to these values here, X and Y. Don't forget, our Y is what? Is the negative, right? Let's say we have it like this. The y is -2 here, right? Y our x is 0, which is on the origin here. So they meet here, right? So if you look at it, on which quadrant? Don't forget, this is the first quadrant, this is the second, this is the third, and this is the fourth quadrant. So is it 90 degree I'll pick, or 270? So I'm picking 270 degree. Why am I picking 270 degree? Because it falls on where? On the third quadrant. Don't forget, this is 0, this is 90 degree, this is 180 degree, and this is 270 degree. Why this is 360 degree? So you see that, which one am I going to pick? The y and the x, the values of my Cartesian form falls on the what? Third quadrant. So I can't pick what? 90 degree. So I'm picking 270 degree. You understand it now? So we can say since the complex number falls on the third quadrant, therefore my theta will be what? 270 degree. Now that is that on theta. Now let's go for what? Let's go for the magnitude, which is r. So how do you get the r? Using, what is the formula? Using r equals to square root of x squared plus y squared, right? This is the formula we proved in the previous video. Now what's our x? 0 square plus what's our y? You put it in bracket, -2 square. You have to put it in bracket too, so that you not have issue. So that will give us 0. 0 square is 0, right? Then plus -2 square will give us 4, right? So that will give us square root of what? 0 plus 4 is what? 4. So therefore our r is what? Square root of 4 is what? 2. Square root of 4 is 2. Then you will now later put it in the last formula. What is the last formula? So what is the last formula? That's z equals to r cos theta plus I sin theta, right? This is the last formula. So what will be your complex number now? What's our r? That's 2 cos, what's our theta? 270 degree plus I sin 270 degree, and this is the final answer. So I hope you understand how you convert from Cartesian form to polar form. And for example, let's say you are given in polar form like this, and they ask you to convert back to Cartesian form. It's still simple. From this formula, just compare with this formula. Let's say this is the question they give us. From this formula, just compare with this z equals to r into bracket cos theta plus I sin theta. So what do you now say? You now say where your r, what is our r representing? 2. What is our theta representing? 270 degree, right? If you compare this with this, now don't forget the two formulas I gave you were x, r cos theta, abi, and y, r sin theta, right? So what do you now do? So that will be x is equals to, what's our r? That's 2 cos 270 degree. And what will be your y? That's 2 sin 270 degree, right? So what is this x going to be? X will now be equals to 2 multiplied by cos 270 will give us what? 0. Let's press the calculator just to be sure. Press cos 270, 0. So 2 multiplied by 0, our x is what? 0. Then that will be y equals to 2 times sin 270 is what? -1. Let's check. Sin 270 -1. So that's 2 multiplied by -1. That was y equals to what? -2, right? So what do you now do? You now later put it inside the complex number, which is z equals to what? X plus iy, right? So that will be z equals to, what's our x? 0 plus I. What's our y? That's -2. So when you put inside bracket, that will be z equals to 0 minus 2i. So you see that we've gotten the complex form now. Do you understand? So this is just very, very simple. Just very, very simple. So you can be given in polar form to convert to Cartesian form, and you can also be given in Cartesian form to convert to polar form. I hope you understand. Please, if you find this video helpful, please do well to like and share this video. Like and share. And if you need one-on-one tutoring, reach out to us. We're always willing to help. Thank you.